All right, folks, today we have 7.2. 7.2 is, we're going to look at volume. And we're going to take cross sections of things we did in 7.1. This is part 1, meaning that 7.2 has a couple of parts to it. Let's bring you back to geometry. Geometry, let's find the area in terms of S, where that S would be the side length of these different figures. This is an equilateral triangle. So S is on all the sides. To find the area of this triangle, what I would do, I would drop a perpendicular, then that would make this side S over 2, S over 2. And since it was equilateral, this is 60, okay, this is 30, and now this is 90. So I know this has to be the square root of 3s over 2. So to find the area of this triangle, it's going to be 1/2 base times height. So I will get square root of 3 times over 2 times 1/2. So times 1/2 means this is 4 times s squared. These formulas you need to know. All right? So that's the equilateral triangle. This is the square. I saved this one for last. Well, not even close. But the square is, not everybody all at once, s squared. That one's easy. Okay? Next, we have a semicircle. Nice, nice. Semicircle. And in the semicircle, if I call this whole thing S, I was doing it in black. If I call this whole thing S, to find the area, it's the radius, which is S over 2, times pi, the radius squared actually, times pi, but now I've got to take half of it. So that's what I get. So actually, when the smoke clears on the mathematics here, it becomes pi s squared over 8. That is a formula you have to know for semicircles. All right, semicircles. The last one is an isosceles right triangle. I'll abbreviate it a little bit. So these are bringing you back from geometry. And in the isosceles right triangle, I'm going to make this guy, actually, you probably would write it like this. Where that's this is 45, and this is 45. And if I called these two S and S, what's the formula? 1/2 base times height. So it's S squared over 2. So those are the formulas. This is one formula for the isosceles right triangle. That's for the semicircles going up here, for a square, and for equilateral triangles. You might say, well, why the heck do you need that? Well, let's look at this next problem. Next problem says cross sections. Oh, formulas. Here they are. Not too bad. Volume is the A of x dx if it's perpendicular to the x-axis. Perpendicular to the y-axis is dy. Let me tell you what we're going to do, just maybe. You get an area. You get some area. Maybe that looks like the area. And what we're going to do is we're going to make a three-dimensional figure by, on top of that, putting like equilateral triangles, like that. So you're going to get some three-dimensional figure and find the volume of it. All right? Let's show you. Find the volume with cross sections perpendicular to the x-axis using all three of them. All three of these. Equilateral, squares, semicircles. I didn't put the isosceles right in there, because if you can do these three, you're pretty good. So, and here's the functions. They're given. This function, that function, and x equals 0. All right, so that means x equals 0 here, and those two red function and green function. And remember, we want to know which one is greater. So we know they intersect, they're going from 0 to 2. So I'm picking a number, carry like 1. All right, and if I plug 1 in, here I get, at this point, I'll get 1/2, and here I'll get -1/2. So I know this guy must be greater. Okay, and now the formula goes, since I want equilateral triangles, it's going to be this, the integral of the equilateral triangle formula. from back there. And that's going to be, I think, the square root of 3 over 4s squared. Okay? So that's how we're going to handle this. Well, s turns out to be just the subtraction of those. All right? And the subtraction of these is square root of 3 over 4 times 1 minus x over 2 minus the smaller one, negative 1 plus x over 2. And this is all squared, there it is, all squared dx. Because the base of this is the area, and then the volume is taken care of by the equilateral triangle thing. So let's do this problem analytically. We got 1 plus 1 is 2. We got negative x over 2, negative x over 2. That's 2 negative x's over 2, which is just minus x squared. Turned out to be nice dx. Now, I should probably FOIL that out and then do the integral. So that's what I'm going to do. So I'm going to take this and FOIL it out. This is 4 minus 4x plus x squared dx. Now we're going to take the integral. We integrate and we get square root of 3 over 4 times. This becomes 4x. This becomes negative 4x squared over 2, or negative 2x squared. And then this one becomes plus x cubed over 3, all evaluated. And by the way, it's from 0 to 2. All right? 0 to 2. Where they intersect. It was bounded by this x equals 0 here. So x equals 0 to 2. They only intersect at one point. So this is going to be 0 to 2, 0 to 2. Sorry, I didn't say that earlier, but you get the hint, I hope. Now I'm going to evaluate this at, guess what? 0 to 2. So now when I plug in 2, I get the square root of 3 over 4. Then I get 8 minus something. Maybe it's minus 8. Fantastic. Oh, I can't close the parenthesis yet. Sorry. And then I get plus 8/3. Now when I plug in 0, yes, it's all 0. My answer to this problem just becomes 8 square roots of 3 over, I guess, I could simplify it, or over 12. And then I'll simplify that by 4, and it'll be 2 square roots of 3 over 3. If I use the calculator, 2 square roots of 3 over 3 is some type of units, okay? And that's it. That's your area. That's actually cubic units, because we found volume. All right? Let me show you what it looks like. That's what it looks like. Okay? It's the bottom is right here is the base that what it was, and then we went up to equilateral triangles. 3D figure. 3D figure, so I can do some crazy stuff with it, like rotate it. Okay? All right, is it coming toward you or going away from you? All right, and then I could do it this way. So that's our equilateral triangles. All right? If you wanted to know, by the way, right here is the volume, 1.154. That's what you should get when you do this. Okay, and it looks probably right. Okay, 1.154 looks pretty good. Let me show you the other ones. Let me show you squares. Okay, let me look at my notes. So far, so good, I hope. So I'm going to do 0 to 2. And a square, if you remember, was just s squared. So it's going to be 0 to 2, 2 minus x squared dx. Well, don't do a lot of work, folks. Don't do it. Because down here, isn't that what this was? I just had the square root of 3 out of 4 in the front. So this, I know, comes out to be 8/3. So when I do this problem, this is 8/3 cubic units. All right? Because you just kind of did it. It's fantastic. Let's look at the semicircles. You may even want to start with this one first, if it gives you lots to do. You start with squares first, and anything squared, you know what the answer is, because you took the integral. Look at the semicircles. When I do semicircles, we go back to the formula, just to remind you. The semicircles is pi s squared over 8. So this is going to be from 0 to 2, pi s squared over 8. So let's make that look nice. It's going to be pi over 8 on the outside, because you could bring those, you could bring those numbers to the outside, and then you'll have s squared in the inside. Well, that s squared is just that x minus, or 2 minus x, quantity squared, dx. I know this is 8/3. From the last slide, I did the integration. And now times pi over 8, your answer turns out to be pi over 3 cubic units. Folks, that's it. Let me show you on the wind plot what it might look like. If I made it instead of equilaterals, here's your semicircles. C solid. Let's go C solid. And let's get rid of this. Let's close that out. Let's do semicircles and C solid. Here it is. There's the base, okay? But as you can see, if I rotate it, let's rotate it this way. It's semicircles that now are making the volume. You see it? Awesome. One more, we just did squares. That's not as exciting, but there's the squares, okay? This was the bottom, right here was the bottom, and now the rest are squares, okay? I don't know how you want to look at it. It's kind of weird, but there's the bottom and there's the squares, almost looking like a pyramid if I come back the other way. So that is how, or the figures that we're creating when we're doing these cross sections. All right, I have this for you. I have some homework for you. I would like you, and there's multiple parts, so don't think, oh my God, he's only given us 2 questions, we're the best. It has some parts like semicircles, squares, etc. I want you to do on page 468, 72, and 74. And I only want you to do A, B, and C. All right? They have 3 parts to each, so it's like 6 problems. Do that for homework. Bring it in. I will check it. All right? Give you a grade for homework. Soon we're going to have a, if not next mod, maybe the following one, we're going to have a little quiz here. All right? Surprise or non-surprise, get ready. All right? Bring it. That's what they say. All right, well, I'm about to go to the basketball game. Alex Raring going to score some points here, maybe make some history. So you enjoy. Have a good time.